On July 21st, 2025, the Hubble Space Telescope took a single image of an object that had only been discovered 3 weeks earlier, and inside that image was a detail that astronomers are still arguing about in published peer-reviewed journals more than a year later. It wasn't a hidden message. It wasn't a structure. It was something simpler and, in its own way, stranger. A glow of light extending out from the object in the wrong direction. Every comet humans have ever studied streams gas and dust away from the sun, pushed outward by solar wind and radiation pressure, which is why a comet's tail always points away from the star it's passing. This object's glow pointed toward the sun instead. And unlike the handful of times astronomers have seen something like that before in ordinary comets, this one did not go away. It didn't turn out to be a trick of the angle you were viewing it from. Across more than a dozen independent observatories, on 4 continents, using everything from backyard telescopes to Hubble itself, that sunward glow kept showing up month after month in a shape scientists still can't cleanly categorize using any of the 3 known explanations for why a comet might ever look like that. That object is 3I/Atlas, and this genuinely is one of the most serious open anomalies it has produced, published, tested, and still unresolved. Before going further, it's worth being upfront about exactly what that phrase, most serious anomaly, actually means here, because it's doing real work, not just grabbing attention. It doesn't mean scientists have found proof of anything artificial, and nobody credible studying this object is claiming that. What it means, in the precise, careful language of the peer-reviewed paper that actually documents it, is that a real, independently confirmed physical feature of this comet does not fit cleanly into any of the established categories astronomers use to explain similar features on ordinary comets, a genuinely rare thing to be able to say about any object this thoroughly studied. That's a real scientific milestone, not a synonym for danger or deception, and it's worth understanding exactly why, because the honest version of this story is more interesting than either extreme, an alien spacecraft on one side, or a shrug and a dismissal on the other. Let's go through exactly what it is, what the real experts on both sides of the debate actually think it means, and why the honest answer here is more interesting than either an alien spacecraft or a dismissive shrug. First, a quick reminder of what this object actually is, because the anti-tail only makes sense once you understand what a normal comet is supposed to look like. 3I/Atlas was discovered on July 1st, 2025, by the Atlas Survey Telescope in Rio Hurtado, Chile, part of a network built to scan the sky for objects that could threaten Earth. Within days, astronomers confirmed its orbit was hyperbolic, meaning it was never bound to our sun's gravity the way every native planet, asteroid, and comet is. It came from another star system entirely, making it the 3rd confirmed interstellar visitor in human history, after Oumuamua in 2017 and Borisov in 2019, and the best studied of the 3 because it was found early enough for the James Webb Space Telescope, Hubble, and a global network of ground observatories to actually turn and watch it for months. It reached its closest point to the Sun on October 30th, 2025, made its closest approach to Earth on December 19th at a safe distance of roughly 270 million kilometers, and has been heading back out toward interstellar space ever since, on a path that will eventually carry it permanently beyond our solar system. Now, the physics of a normal comet tail. As a comet approaches the Sun, sunlight warms its icy nucleus, causing frozen material to sublimate, turning directly from solid ice into gas. That gas, along with dust released alongside it, gets pushed by 2 separate forces, the constant outward stream of charged particles called the solar wind, and the direct pressure of sunlight itself called radiation pressure. Both of those forces push outward, away from the Sun, which is why every comet tail you've ever seen in a photograph streams away from the star it's passing, regardless of which direction the comet itself happens to be moving. That's not a minor detail. It's about as basic and universal a rule as you get in cometary science. So, when Hubble's July 2025 image showed 3I/Atlas's glow extending noticeably farther on the sunward side than the anti-solar side, astronomers immediately took notice because that's backward from what the physics normally predicts. To be fair to the science here, astronomers do already know of legitimate, entirely natural reasons a comet can appear to have a sunward-pointing feature, and it's worth explaining them honestly rather than pretending this phenomenon has never been seen before. The most common explanation is a pure optical illusion caused by geometry, sometimes called a neckline. When Earth happens to pass close to the plane of a comet's orbit, older dust that was ejected many months or years earlier, and which has since spread out into a thin sheet trailing behind the comet on a slightly different path, can appear, purely from our specific viewing angle, to project toward the Sun rather than away from it, even though every individual dust grain is still physically moving away from the star exactly as expected. It's an illusion of perspective, nothing more, and it's been documented on plenty of ordinary comets throughout the history of cometary astronomy. There's also a second, genuinely physical explanation. An active jet on one specific region of a rotating nucleus can eject material preferentially toward the sun, especially from the side of the nucleus, still warmed by daylight, producing a real, physical, sunward-pointing plume that nonetheless comes from completely ordinary, well-understood sublimation physics, nothing exotic required. Here's the actual anomaly, stated as precisely as the researchers studying it have stated it. A peer-reviewed paper published in the monthly notices of the Royal Astronomical Society, specifically examining the physics of 3I/Atlas's anti-tail using Hubble observations, laid out these known categories explicitly: the perspective illusion, the active jet, and a third possibility involving trailing streams of larger, slower-moving dust, and then stated plainly that the anti-tail observed on 3I/Atlas does not fall easily into any one of them. That's a direct quote from a peer-reviewed astronomy journal, not a blog post, not a press release, an actual refereed scientific paper concluding that this specific feature resists clean classification using the existing toolkit astronomers have built up from decades of studying comets native to our own solar system. What made this even harder to wave away as a one-off image artifact is just how persistently it kept showing up. Independent astronomers around the world, using telescopes ranging from large research-grade instruments down to amateur setups a fraction of a meter across, kept photographing the same feature for months. Francois Kugel captured a detailed post-perihelion image on November 17, 2025, showing not one but two distinct sunward jet structures, alongside a longer, more traditional tail pointing away from the sun, an unusually clean and well-defined view. Tony Scarmato and Tirasak Thalawang independently photographed the same tightly collimated sunward structure in mid-December from completely different locations and instruments. A team using the Lasidi telescope at the South African Astronomical Observatory caught it as well, describing it as a distinct dust fan pointed sunward. And critically, this wasn't limited to ground-based amateur imaging. When NASA's Mars Reconnaissance Orbiter used its HiRISE camera, an instrument built to photograph the Martian surface in extreme close-up, to catch 3I/Atlas during its close pass by Mars, that image also showed a glowing extension ahead of the object along its direction of motion, consistent with the same sunward feature, seen from an entirely different vantage point in the solar system, using an entirely different spacecraft months apart from the ground-based sightings. Multiple viewing angles, multiple instruments, multiple independent research teams, all converging on the same unusual observation over a span of roughly half a year, is precisely why this particular feature has held up as a genuine, still-open puzzle rather than getting quietly explained away and forgotten the way most one-off anomalies eventually are. Now let's actually get into what the real experts, on both sides of this, think it means, because this is where the story gets genuinely interesting rather than sensational. David Jewett, an astronomy professor at UCLA and one of the most respected comet researchers alive, offered the mainstream explanation directly, telling Sky and Telescope that the object is ejecting dust particles toward the sun simply because the sunlit side of the nucleus is the hot side, meaning that's exactly where sublimation would naturally be most intense. In his assessment, everything observed remains consistent with a comet nucleus of ordinary size, or even smaller than average, simply sublimating in sunlight and blowing dust outward, and he was blunt in saying there's nothing really shocking there. Jason Wright, an astronomer at Pennsylvania State University, pushed back specifically against the more dramatic interpretation of this data, pointing to previous, if less pronounced, cases of sunward dust enhancement documented in other, entirely ordinary comets, caused by larger dust grains that simply aren't swept away by the solar wind and radiation pressure as efficiently as the tiny grains that dominate a normal antisolar tail. Since bigger grains have less surface area relative to their mass, sunlight pushes them far less effectively, meaning they can linger closer to the sunward side of the nucleus for longer, before eventually being dispersed, rather than getting rapidly swept away into the ordinary tail. That explanation lines up with additional analysis published separately by Harvard's Avi Loeb, working with astrophysicist Eric Quito, who calculated the physical constraints on the particle sizes required to sustain a sunward glow extending as far as 400,000 kilometers from the nucleus, as measured in several of the sharpest images taken in December 2025. Their math showed that ordinary microscopic dust, the kind that dominates most comet tails because it scatters sunlight most efficiently, simply couldn't survive that far in the sunward direction without being blown away almost immediately, meaning whatever is producing this glow has to be made of unusually large particles, larger than what typically dominates the visible glow around solar system comets. That's a real, calculated, physically grounded finding, and it's also exactly the kind of detail mainstream comet experts like Jewett and Wright would say is consistent with ordinary but unusually vigorous large-grain dust ejection, rather than anything exotic. Where the disagreement actually lives is in interpretation, not in the underlying data itself, and it's worth being precise about that distinction because it's easy to blur. Loeb has been open that he considers the full pattern, taken together, the persistence of the anti-tail, its unusually tight collimation, the specific particle size required to sustain it, along with a separate independently measured anomaly in the object's light called extreme negative polarization, a property no other studied comet, including the previous interstellar visitor Borisov, has ever displayed to this degree, as together representing something worth taking seriously as a genuine open question about the object's nature rather than something that can be fully explained by known physics alone. He's floated speculative possibilities, including that a beam of particles or light could, in principle, serve a defensive function against micrometeorite impacts for something built rather than grown, alongside more conservative natural explanations involving unusually large ejected fragments breaking off the sunlit face of the nucleus. It's worth being clear that Loeb himself doesn't claim certainty here. He maintains his own numerical scale for ranking how anomalous an interstellar object appears, from 0, representing an ordinary natural comet, to 10, representing confirmed alien technology posing a direct threat, and he has placed 3I/Atlas at a 4 on that scale, only slightly higher than his own rating for Oumuamua, explicitly below the midpoint, a rating that reflects genuine, documented scientific puzzlement rather than a confident claim of anything artificial. The honest complete picture, then, looks like this. There's a real, peer-reviewed, independently confirmed anomaly here. Multiple respected research teams, using instruments ranging from backyard telescopes to Hubble to a Mars-orbiting spacecraft, have documented a sunward-pointing glow on 3I/Atlas that doesn't cleanly match any of the 3 previously known categories of cometary anti-tail, a genuinely unusual and still scientifically unresolved observation. At the same time, leading comet experts, people who have spent entire careers studying exactly this kind of dust behavior on ordinary solar system comets, see nothing in the underlying physics that requires anything beyond natural, if unusually vigorous, and large-grained dust ejection from the sunlit face of an ancient interstellar nucleus. Both of those statements are true at once, and that's not a contradiction. It's simply what a live, actively contested scientific question looks like while it's still being worked out, rather than after the fact, once a tidy answer has already settled into textbooks. There's a second, entirely separate anomaly worth understanding alongside the anti-tail, because the two findings reinforce each other, and because this one comes from an even more directly peer-reviewed source. In a paper published in the Astrophysical Journal Letters, an international team using 3 separate telescopes, the Very Large Telescope in Chile, the Nordic Optical Telescope, and the 4-Row-2 Telescope in Bulgaria, measured something called the polarization of light scattered off 3I/Atlas's coma, essentially how strongly the light bouncing off its dust cloud gets aligned in a particular orientation, a property that depends heavily on the size, shape, and composition of the dust grains doing the scattering. Comets generally show what's called a negative polarization branch at small viewing angles, but the depth and shape of that branch varies from comet to comet in ways that reflect real physical differences in their dust. What the team measured on 3I/Atlas was a negative polarization reaching a minimum of -2, 7% paired with what's called an inversion angle, the specific viewing angle where the polarization flips from negative to positive of just 17 degrees. According to the published paper, that specific combination, that particular depth of negative polarization together with that particular inversion angle, is unprecedented among every asteroid and comet ever measured this way, including Borisov, the only other interstellar object ever studied with this technique. The paper's authors described 3I/Atlas as representing a previously unobserved population, a genuinely notable statement to see stated plainly in a peer-reviewed astrophysics journal. It's worth being precise about what a finding like that actually tells scientists, because polarization measurements are a real, established quantitative tool in cometary science, not a vague or subjective observation. The specific way light polarizes when it scatters off dust depends on the physical structure of that dust, whether the grains are compact or porous, roughly uniform in composition or layered, similar in size to the wavelength of light or dramatically larger or smaller. An unprecedented polarization signature is, in the most literal sense, direct evidence that the dust surrounding this object is structurally or compositionally different from the dust shed by every other comet ever measured this way, including the previous interstellar visitor. Researchers studying the result have suggested this points toward dust that formed under conditions genuinely different from anything in our own solar system's history, which lines up naturally with the isotope-based age, estimates suggesting this object may predate our solar system by billions of years. Once again, that's a real, measured, published anomaly, and once again, the leading interpretation among the researchers who actually collected the data is that it reflects an ancient interstellar object's genuinely different formation history, not anything artificial. There's a third detail worth mentioning, honestly, because it's part of the same broader pattern of unusual coincidences this object has produced, even though it deserves more caution than the anti-tail or the polarization measurement. 3I/Atlas's trajectory through the solar system is tilted retrograde, meaning it travels opposite to the direction every planet orbits the Sun. That retrograde path happens to align with the ecliptic plane, the flat disk in which the planets orbit, to within about 5 degrees. For a randomly incoming object arriving from interstellar space with no reason to prefer any particular orientation relative to our solar system's disk, landing this close to that plane by pure chance is statistically unlikely, and Loeb has calculated the odds of it at roughly 0.2% under a simple random direction assumption. It's a genuinely interesting orbital coincidence, and it's worth being upfront that most researchers studying it treat it exactly as that, an interesting coincidence, rather than as strong evidence of anything. Statistically unlikely things happen constantly across a large enough sample, and astronomers have only tracked 3 interstellar objects in total, an extremely small sample size from which to draw firm conclusions about what's typical or atypical for a naturally arriving visitor. It's the kind of detail worth mentioning honestly as part of a full accounting of this object's unusual features, without overstating what a small sample coincidence can actually prove on its own. The polarization anomaly also came with its own genuinely rare scientific opportunity, one worth understanding, because it shows how seriously the astronomy community treated the chance to study this object's dust properly. Researchers calculated that on January 22, 2026, 3I/Atlas would align to within an extraordinarily small angle, less than a single degree, with the Earth-Sun axis, a geometric configuration astronomers call a near opposition alignment. At that specific alignment, an effect called the opposition surge becomes measurable, a sharp temporary brightening that happens when sunlight reflects almost directly back toward an observer without any shadowing between individual dust grains, and the exact shape of that brightening spike provides an unusually direct, well-constrained window into the structure and packing of the dust itself. Researchers explicitly noted this kind of alignment might not repeat for decades, meaning the data gathered around that single date represented a genuinely unrepeatable opportunity to characterize the albedo and structure of a piece of interstellar matter more precisely than almost any other measurement available. That's not the language of researchers treating this as a minor curiosity. It's the language of scientists who understood they were getting one clean shot at a measurement that might not be possible again in their lifetimes, on an object that will never pass through our solar system a second time. There's also a chemical piece of this story worth folding in, because it adds yet another layer to the picture of just how different this object's composition is from typical solar system comets. Spectroscopic analysis of the gas surrounding 3I/Atlas found its coma dominated overwhelmingly by carbon dioxide, making up roughly 87% of the gas by mass, with carbon monoxide contributing about 9% and water making up most of the small remainder, a ratio that stands out sharply against typical solar system comets, where water usually dominates far more heavily. Researchers also detected trace amounts of nickel without any accompanying iron, an unusual pairing, since the two metals typically appear together in comet dust from our own solar system, alongside detections of cyanide, both of which were found to increase sharply as the comet drew closer to the Sun and its outgassing intensified. None of these chemical findings suggest anything artificial either. Comets forming under different conditions around different stars would reasonably be expected to show different starting chemistry, but they add up to a consistent, repeated pattern across nearly every measurement technique astronomers have thrown at this object. Methane ratios, unlike anything in our solar system, deuterium enrichment, unlike anything in our solar system, dust particle sizes, unlike anything in our solar system, polarization behavior unlike anything ever measured, and now a bulk gas composition dominated by carbon dioxide rather than water in proportions well outside what's typical, even among the more carbon dioxide-rich comets native to our own solar system. Every previous comet studied in this kind of detail formed inside our own solar system, subject to the same basic conditions, the same range of distances from the same star, the same rough mixture of starting materials. 3I/Atlas almost certainly did not. Earlier analysis using isotope ratios captured by the James Webb Space Telescope suggested this object may have formed somewhere between 10 and 12 billion years ago, meaning it could be 5 to 7 billion years older than our entire solar system, condensing out of material in a completely different region of the galaxy, under conditions we have no direct experience studying up close. If its dust grains genuinely do behave differently under sunlight than anything we've measured before, whether that's because of unusual size distributions, unusual composition, or some structural property of the ice holding those grains together in the first place, that's not evidence of anything artificial. It's potentially direct physical evidence that material formed around a completely different star under completely different conditions doesn't necessarily behave exactly like the material that built our own solar system, which is precisely the kind of genuinely new scientific information a rare interstellar visitor like this was always the best chance of actually providing. It's also worth being clear-eyed about where the actual scientific consensus currently sits, because that's easy to lose track of in a story built around genuine, ongoing disagreement. NASA's own public materials on 3i/Atlas consistently describe it as a natural comet, and multiple dedicated searches for artificial radio signals, run by the Breakthrough Listen initiative using the Green Bank Telescope, and separately by the SETI Institute's Allen Telescope Array, found no evidence whatsoever of engineered signals coming from the object. A conclusion published plainly and without ambiguity. The overwhelming majority of astronomers actively studying this object, including the researchers who authored the peer-reviewed paper on its anti-tail physics, treat the sunward glow as a genuine, currently unexplained detail of comet behavior worth continued study, not as evidence pointing toward anything built rather than grown. Loeb's more speculative framing represents one prominent researcher's minority interpretation of an admittedly strange dataset, not the position of the broader field, and it's worth holding both of those facts in your head at the same time, that the anomaly is completely real and worth caring about, and that the leading, most probable explanation for it remains entirely natural. That distinction is worth sitting with, because it's exactly the kind of nuance that tends to get lost the moment a story like this gets compressed into a headline. Saying the anti-tail is the most serious anomaly 3i/Atlas has shown to date doesn't require inventing anything, and it doesn't require ignoring the mainstream explanation either. It requires holding a genuinely uncomfortable, honest scientific position. Real data, gathered independently by multiple credible teams using multiple different instruments, that doesn't yet fit cleanly into any of our existing models, alongside a leading natural explanation that remains, by the assessment of the field's own most experienced comet researchers, the most likely answer once all of the physics is accounted for. Science doesn't always hand you a clean, satisfying resolution on the timeline a headline demands, and the fact that this specific question remains genuinely open, argued out in real peer-reviewed journals, rather than settled in a single press release, is precisely what makes it worth understanding accurately rather than flattening into either extreme. As of the most recent updates from researchers tracking the object, 3i/Atlas has continued fading as it moves farther from the Sun, crossing outward past Jupiter's orbit in March of 2026 and continuing on towards Saturn's orbit later this year. Its brightness slowly dropping as the outgassing that produced its coma and anti-tail alike gradually quiets down with distance from the Sun. Whether that fading anti-tail ultimately gets folded neatly into an updated model of large-grain dust ejection from ancient interstellar nuclei, or whether it remains a stubborn, unresolved detail astronomers are still debating years from now, is genuinely still an open question. And that open-endedness is not a weakness of this story. It's the actual honest state of a real scientific puzzle, still being worked out in real time by real researchers using real data gathered from an object that will never pass this way again. If you found this useful, that's your reminder that the most serious anomalies in real science rarely resolve into either a clean confirmation or a clean dismissal on the timeline a headline wants. They stay open, argued over in journals, for exactly as long as the data demands, and that's precisely what's happening with 3i/Atlas's anti-tail right now. Follow along for more of these, because this object is still fading out there as we speak, and whenever the next paper lands, whichever way the evidence actually points, we'll be here to walk you through exactly what it says, straight from the published research, not from whichever version of the story travels the fastest.